conferences and know that they can be creative and engaging. So what I'd like to do next is to share my screen and begin my presentation. So hopefully you can see the first slide, which has my name and affiliation. And what I'd like to do is, let's see, all right. So first, again, it's an honor to participate in today's virtual conference. This theme of engaging and supporting students in a changing world is certainly one that has always been prominent, and even more so in the last 6 months as COVID-19 has dominated our lives in unexpected ways. It's difficult to imagine life before this pandemic hit, which has impacted not only our health, but also education from pre-K through higher education, and also into our workforce. It has uncovered and exposed inequities that we know have long persisted. And as we do not yet know the long-term impact of COVID-19 on our education communities and the workforce, and as the nation is engaged in conversation about race and inequity, it remains important now more than ever that we re-examine the STEM ecosystem. In 1983, first I want to tell you a little bit about my background, and the bio did share a little bit about my educational background. And I know it sounds like I did a lot of job hopping at NSF, but we have something called details. So you get to, I feel like it's the best system in the world. You get to try out new positions if there's a need to fill a vacancy while a job search is going on. So I actually graduated from Loyola, as was mentioned. When I went, it was Loyola College, now it's Loyola University in Baltimore in 1983. With a bachelor's degree in biology. And my first job was at the National Aquarium in Baltimore, which until that time, I really had not heard about informal science education, which is science learning that takes place outside of the formal K-12 classroom. This job enabled me to address the issue of limited access for groups that are historically underrepresented in science, especially those living in Baltimore City and the surrounding areas where the aquarium is located. This was of special interest to me because I grew up in Baltimore and attended Baltimore City Public Schools. While I know that there can be, and I experienced being taught by some incredibly strong teachers, I also realized that there are many challenges that exist in public schools and with the students themselves. As part of my responsibilities at the aquarium, I developed and delivered programs for students and teachers during my 14 years there. As director of education, which was the last position that I held before leaving, I was able to advocate for and obtain funding to support year-round youth enrichment programs, which led some participants to actually pursue degrees and careers in science. I was also an education consultant, as was mentioned, and one of the really fun things that I did was to write children's books on marine animals. Informal STEM learning offered by the aquarium and other museums and science centers plays an important role in illuminating science for the public. At that time, however, STEM participation rates for women, African Americans, Native Americans, and Latinos were much lower than I expected. Unfortunately, nearly 40 years later, work still needs to be done to make science inclusive. This slide shows information that is pulled from the 2019 Women, Minorities, and Persons with Disabilities in Science and Engineering report that's produced by the National Science Foundation's National Center for Science and Engineering Statistics. It shows that 41% of science and engineering research doctorates were awarded to women in 2017. They make up more than 50% of the population and 47% of the workforce. However, 11% of the science and engineering research doctorates were awarded to people historically underrepresented in STEM, those groups that I mentioned, who represent 27% of the population and nearly 30% of the workforce. So you can see that there's a discrepancy there. This report shows that representation of women, persons with disabilities, and underrepresented groups in science and engineering, which I'll abbreviate as S&E, is smaller than their representation in the US population. While women have reached parity with men among S&E bachelor's degree recipients, they're still generally underrepresented in S&E occupations. Likewise, as the statistics show, Blacks or African Americans, Hispanics, and Latinos, American Indians, or Alaska Natives have gradually increased their share of S&E degrees, but remain underrepresented in the S&E educational attainment and the S&E workforce as a whole. While we've seen some increases since between 2000 and 2016, where, for example, the bachelor's degree attainment was 16% in 2000 and 22% in 2016 for groups underrepresented. Again, it's still not at the same level of that these groups are represented in the population of the United States. The science and engineering enterprise faces the same diversity, equity, and inclusion challenges that are present in society. These issues prevent the US from having a STEM ecosystem that is representative of the incredible diversity we see in our country, a diversity that is essential to maintaining US global leadership in science and engineering. Different experiences and perspectives are vital to the scientific process. They help to spur creative solutions to difficult problems and ensure that new technologies and innovations can benefit all of us. So what will it take to truly have diversity, equity, and inclusion in STEM? This is one of the questions that I was asked to respond to as part of my presentation. This slide helps to answer that question, as here it is imperative that we focus on our untapped domestic talent, which will help us bring into fold what some people refer to as the missing millions. I'll say more about this, but I just want to call your attention to the legend that each figure represents 100,000 people in the science and engineering workforce, those that are shaded. Those that are unshaded are the additional people, times 100,000 for each figure, that are needed in 2030 for the science and engineering workforce to be representative of the US population. Recognizing the importance of a diverse pool of STEM talent, the National Science Foundation has long championed programs that broaden participation of groups historically underrepresented in various scientific disciplines. In fact, you may already be familiar with a number of projects and programs or receive some support for programs such as, and I will continue to repeat the program names and try not to slip into the heavy use of acronyms. But the Alliances for Graduate Education and the Professoriate, or AGAP, the Historically Black Colleges and Universities Undergraduate Program, HBCU UP, Research Experiences for Undergraduates, REU, the Graduate Research Fellowship Program, GRFP, the Lewis Stokes Alliances for Minority Participation, which we affectionately refer to as LSAMP, the Tribal Colleges and Universities Program, or TCUP, and the Hispanic Serving Institutions Program, or HSI. NSF has long embraced and invested in programs that support women and groups historically that have not been well represented in STEM. Investments in which we hope will enable these groups to have the same level of representation in the STEM workforce that they have in the US population. The agency has a dedicated broadening participation portfolio representing nearly $1 billion, a $1 billion investment. In 2019, it was $1.2 billion. with programs that aim to prepare a diverse, globally engaged STEM workforce. It has programs that work to bring STEM education to rural and economically disadvantaged areas, and research grants that focus on creating research opportunities in areas that have historically lacked such infrastructure. I want to highlight a few of these programs, but I will focus on those that recruit, retain, and advance groups historically underrepresented in STEM. The first program is the Historically Black Colleges and Universities undergraduate program, and I'll say a little bit more about the center that's highlighted in this slide. NSF supports HBCUs through this program, along with the Centers of Research Excellence in Science and Technology, or CREST. Both of these programs have their foundation in efforts to broaden the participation of groups in STEM. They are two of NSF's established and long-standing programs. They're models for expanding the participation of Black, African American, and Hispanic students and building, very importantly, research capacity at these institutions. Over the years, the HBCU Up program has seen quite a measure of success. As a testament to its growth, NSF recently announced a new HBCU Broadening Participation Center to study successful undergraduate STEM education practices at historically Black colleges and universities. This center is funded at a level of nearly $9 million over 5 years. Data collected will help explain how the educational advocacy and social support provided by HBCUs consistently produce a greater sense of well-being, higher percentages of STEM graduates, and ultimately STEM doctorates. I'm happy to say that after earning my bachelor's degree in biology at Loyola and master's at Johns Hopkins, as was mentioned, I obtained my doctorate in science education at an HBCU, Morgan State University in Baltimore City. The next program I'd like to describe is the Tribal Colleges and Universities undergraduate program. NSF provides awards to tribal college, through this program, tribal colleges and universities, Alaska Native, and Native Hawaiian serving institutions to promote high quality STEM education, research, and outreach for Native populations. The Tribal Colleges and Universities program, or TCUP, was launched almost 20 years ago. Through NSF's steadfast support, numerous tribal colleges have developed STEM degree programs and evolved from 2-year to 4-year institutions. For example, Navajo Technical College, now Navajo Technical University, developed an engineering bachelor's degree program that was fully accredited by ABET, or the Accreditation Board for Engineering and Technology, in 2018. Navajo Technical University was the first tribal college to earn this very prestigious ABET accreditation. As of last year, 14 students have graduated from the program and gone on to graduate school or into high-paying jobs in industry. Some have even started their own companies. Since 1999, NSF has invested in the Alliances for Graduate Education and the Professoriate, or the AGAP program. The goal of AGAP is to increase the number of faculty from underrepresented groups in specific STEM disciplines and education research fields by advancing knowledge about pathways to career success. AGAP has successfully evolved from changing the academic landscape to advancing knowledge about underlying issues, policies, and practices that affect the participation, transition, and advancement of underrepresented groups. Some of you may be familiar with the ADVANCE program, which aims to increase the representation and advancement of women in the academic STEM workforce. This program focuses on developing innovative and sustainable ways to promote gender equity through enhancing institutional structures, work-life support, equitable career support, and empowerment. Over the nearly 20 years that ADVANCE has been in existence, more than 160 institutions of higher education have received funding. Next, I'd like to share a little bit about one of our newer programs. In 2018, after holding listening sessions with the Hispanic serving institution community and obtaining input from experts knowledgeable about these institutions and STEM education at HSIs, NSF formally established the Hispanic Serving Institutions Program, or HSI, to enhance the quality of undergraduate STEM education and to increase the retention and graduation rates of students pursuing degrees in STEM at HSIs. Additionally, this program aims to build the capacity for STEM research and education at Hispanic serving institutions that typically do not receive high levels of NSF funding. We also recognize that the creation of STEM pathways and opportunities in STEM is one of the best ways to ensure that our nation remains competitive. The LSAMP program, or Lewis Stokes Alliances for Minority Participation, provides mechanisms for increasing participation and the educational preparation of students from underrepresented groups who graduate with a degree in a STEM discipline. The LSAMP program provides support for 57 alliances of institutions, which represent more than 650 partnerships and has helped more than 650,000 students from groups historically underrepresented in STEM to attain bachelor's degrees in science or an engineering discipline. It also provides funding for students to pursue graduate degrees in STEM as well. And while NSF's support of these programs has yielded tremendous impacts, addressing a problem this extensive needs big solutions. One that engages not a single group, but key stakeholders from business and industry, educational institutions, community organizations, nonprofit funders, and government agencies to work collectively towards the same goals. As many of you know, this is the vision of the inclusion across the Native of communities of learners of underrepresented discoverers in engineering and science initiative, or NSF Includes, which is one of NSF's big ideas that will shape the future of science and engineering. Now in its 5th year, NSF Includes has engaged more than 37,000 individual participants and more than 1,200 partner institutions in 49 states. Projects draw from proven strategies to create inclusive learning environments and build pathways into STEM careers for students. In July of this year, NSF released its NSF Includes Report to the Nation 2, which outlines the progress that the program has made. I encourage you to download that, and if I have an opportunity, I'll put the link in the chat. We're happy that our new director, the new director of the National Science Foundation, Dr. Panchamathan, sees the effectiveness that NSF Includes has had and the promise that all of the portfolio of awards represents, and indicated in his remarks what's really bold about the approach that's being used by NSF Includes, focusing on developing intentional collaboration and networks that are committed to common agendas and systemic approaches to solving STEM specific inclusion challenges at a national scale, which is what distinguishes NSF Includes from some of our other broadening participation programs. It's funded the alliances, which First to STEM is one of these alliances, are designed to scale up evidence-based approaches to solving particularly sticky broadening participation challenges. As innovative stakeholders and members of the statewide NSF Includes funded First Two Network, you know that the approach of NSF Includes to building large-scale networks is key to developing and sustaining the kind of systemic change across systems that is needed to move the needle on inclusivity in STEM. NSF includes something called a collaborative infrastructure approach, and the 5 components of collaborative infrastructure are represented by the hexagons here. Identifying goals and metrics within each alliance and across the NSF Includes National Network, ensuring that there's leadership and communication. For any of you that have participated in partnerships, I'm sure you know that if there isn't communication across all of the collaborating members, then things can get a little bit unstable. Shared vision, this is really key, having a shared vision for what is to be achieved and how the specific broadening participation challenge will be addressed. Partnerships, a key component of NSF Includes. I mentioned that across all of the projects, more than 1,200 partnerships are represented. And then expansion, sustainability, and scale. All of these elements are critical, but the expansion, as I said, to scale up from pilot projects that were funded to national or regional projects is critical. Sustainability, NSF, you know, I was a program officer before moving into my current position, and I saw a lot of grant proposals where people had great ideas, but they hadn't really thought about how the work would be sustained beyond the NSF funding. So with these alliances, we're giving 5 years of funding to help, you know, with the initial years of sustainability, but we hope that First to STEM and the other alliances will be, you know, robust long after that as well. And I mentioned scaling up from small regional projects or test pilots to regional or national projects. The collaborative infrastructure approach used in Includes gives the scientific and educational community a new approach that centers working together to implement multiple research-supported strategies can be scaled up. As a community, we need to build inclusive environments and hiring practices for learning at universities and in K-12 education environments. We need more mentors from diverse backgrounds and opportunities to engage in research experiences at the undergraduate level. We need a culturally sensitive curriculum, and we need to show that the culture of STEM is not solitary, but can be an interactive place where teams collaborate on innovations that help people. These strategies can only be successful if stakeholders work together, step by step, to eliminate the traditional barriers that have kept promising young scientists, engineers, mathematicians, and educators from careers in STEM. So I'll stop here because I'd definitely like to leave enough time for us to engage in discussion. I'm sure that through this presentation, you may have thought of questions, and I'll stop sharing and do my best to answer any questions that you might have. I hope that there's some questions out there. I know that I provided a lot of information, a lot of details on NSF programs because we definitely want all of you to consider applying for programs beyond NSF Includes. What I used to tell folks when I did outreach, and I still mention this, you know, individual programs, NSF Includes, the budget is anywhere from $18 to $20 million each year. The budget of NSF, I think, is about $8 billion these days. So look beyond one program. There are lots of other opportunities for organizations that have an interest in STEM and STEM education to consider applying. Specifically for education, I believe the Director for Education and Human Resources, our budget is now about $900 million or so, going from memory, but you can definitely look into all of that on the NSF website.
I have a question for you, Dr. James. It's
Sure,
Sue Ann.
and please call me Sylvia.
Okay, Sylvia, it's Sue Ann. You can call me Sue Ann. Can you tell me a little bit more about the work within Includes or others to engage other agencies and how that's shaking out, other agencies that have a shared vision with NSF with regard to inclusion in STEM programming?
Sure, that's a great question. And my interpretation of the question, when you say other agencies, I'm thinking other federal agencies. So I'll tell you what we're doing specifically. In 2018, the federal government released a 5-year strategic plan for STEM education. And under the auspices of what's called FC STEM, or First Co-STEM, Coordination in STEM. And there are more than 10, probably 15 agencies that are members of Co-STEM. And at the implementation level, it's called FC STEM, Federal Coordination in STEM. And so all of the agencies involved embraced this new 5-year strategic plan. It was followed on the heels of one that was completed in 2017. And prior to the release of that new plan, the director of the National Science Foundation at that time, who was Dr. Franz Cordova, she approached these agencies and said, we want you to commit to becoming a member of the NSF Includes National Network. We realized that that we have different missions as federal agencies, but one thing we can agree on is that, as federal science agencies, I should say, but the one thing that we can agree on is the need to broaden participation in STEM. Some of these agencies have internship opportunities, and they can't fill them, that are targeting diverse populations, and they are not able to get enough students to apply. Some of them have, programs like NSF. Not all of them are grant funding agencies, but we recognize that on this we can agree, and that's one of the pillars in the 5-year plan. Which thank you, Yulia, our science assistant, has put a link to the plan and a progress report, America's Strategy for STEM Education, the 5-year strategic plan, in the chat. But we recognize that federal agencies can come together on that. And since that time, I think we've had 6 agencies commit to joining the NSF Includes National Network, which goes beyond just NSF funded grantees. So if any of you are not part of, or if you're part of First to STEM, but you don't have an NSF grant and you think, well, what can I do? You can join the NSF Includes National Network. There are lots of resources that you can take advantage of. There are affinity groups that want to focus on specific issues, like an engineering affinity group that was actually formed as a result of a convening that NSF had with NASA. NASA has a program, the acronym is MIRA, Minority Undergraduate Program, and I don't remember the rest of the acronym, but they wanted to bring together their principal investigators with folks from NSF, and NSF includes grantees to see if there were ways that we could work together. And so that was part of what we hope to accomplish by having other federal agencies join the NSF Includes National Network, highlight their funding opportunities, collaborate with NSF, and in some instances we can fund projects together. make everyone in their awardee pool, individuals who have grants at the Department of Education or NASA and other federal organizations, aware of the funding opportunities that NSF has. So that's probably not a very succinct answer, but one that helps to share a little bit about how we envision working with federal partners at the national level, but within the projects, we see lots of collaboration with local at the state level agencies to support the work that's being done in the alliances. And also we have planning grants that have been funded. And prior to that, we had pilot projects, 70 pilot projects were funded through NSF Includes.
It's hard to know when to jump in here, Sylvia. We have so many questions for you. How long can you stay with us? So I had a couple questions. I'm going to narrow it down to one for right now. And when you talk about these projects that are coming out of the Includes investment, including First Two, I'm wondering if you have a story or an example or some role models for us as we grow and find our feet under us in terms of getting to that place where we become a regional and a national real anchor for the work that we're doing, what we're learning, how we share that. That's all uncharted territory for us. We're feeling our way through it. I think so far we're making progress, but it's definitely unknown for us. And I wonder if you have any thoughts or examples for us of somebody that's walked that path before us in a similar way that might be good role models or mentors for us.
Okay, that's a great question. I think that, you know, what I observed as a program officer and in other positions at NSF, that one thing that you can do is certainly to reach out to others, as you've indicated, you know, who are the other grantees who've been able to you know, successfully chart this path, go from a pilot to a national level project. A number of things that I would recommend. One, definitely attend the principal investigator meetings, what we call PI meetings, because of course they're probably going to be virtual. The one for next year will likely be virtual. But I can't underestimate the value of networking with other grantees, because within NSF Includes, you have some folks like you who are, you know, new to NSF and new to being a part of a large national network or leading a national network, but mixed in there, you have people who have had NSF awards before that have been able to successfully implement small and large multi-year projects. So I think the one project in particular is CASI, and I don't remember the let's see, Computing Alliances for Hispanic. I can't remember what the SI stands for, but CASI is another one of the NSF Includes networks. Prior to receiving the NSF Includes award, they had funding, I believe it was from our Directorate for Science and Engineering Education, to implement a smaller level network, what they call broadening participation in computing alliances. So that's an example of an organization that has lots of prior experience, and I think Yulia put that in the chat as well, the link for CASI. So you have a variety, you have principal investigators with a variety of expertise. The other thing that I would recommend is to not limit yourself. Well, of course, participate in all of the activities that you can on the national network and the especially the affinity groups where you can interact with folks who have common interests. But the other thing that I would suggest is not to limit yourself just to NSF Includes. If you search for, on the NSF NSF awards database, and you find a project that is doing something not identical to what you're doing, but somewhat comparable, in terms of working with rural populations, first generation students, reach out to the PI. Ask them about some of the roadblocks that they've run into and the ways that they've overcome them. Because while the First Two network is unique, and in terms of how you're implementing using the collaborative infrastructure approach of NSF Includes, there are other projects that may have some similarities and components, probably especially in the Advancing Informal STEM Learning program, as well as ITEST, which is a program, ITEST, Innovative Technology Experiences for Students and Teachers, which sort of straddles K-12 and out of school. So within those two portfolios, I know that there are probably some principal investigators that you might want to chat with. You can invite them to, speak to your team, et cetera, to learn a little bit about more of what they've done and how they may have addressed some sort of challenges, roadblocks that they encountered along the way. So my recommendation is to, and of course, I keep saying, and like I'm finishing up, stay in touch with your program officer. Your program officer is your friend. A lot of people are a bit intimidated by, the program officers because, they seem crazy busy. And they may be, but they should always make time for you. If you have questions about, things related to your project, the Includes program, et cetera. But one way that we, hope to ensure that you have additional support beyond the program officer is the national network. So that network is, a set of resources that are designed to provide a tremendous amount of support for the NSF Includes awardees. And so, just having overcome that hurdle to be among the first to receive these alliances, we know and we have confidence that you will be successful. And I know that with the team that you put together, because it's very competitive, it's a unique program, trying different approaches. If you were fortunate enough to be among the first awardees, that means that your plan was top of the line. And the review process. You have reviewers who are going to go through those proposals with a fine-tooth comb. And I would say that is the first measure of success that you should look at. In addition to that, take advantage of all of the resources, some of which that I've mentioned, that will help you answer any questions you have. Don't be afraid to ask questions that will help you to move forward and be successful in the remaining years for your project, because I think you're in year 2, correct? 3, okay, yes. So you're halfway there. I hope that helped.
I see something in the chat from Debbie Shaver.
Let's see, the Office of the Waters of Systems Change state that to achieve transformative change, you need to change mental models, the implicit narratives people have about a problem. Do you have advice on how to change mental models for broadening participation in STEM? That is a good question. I guess my initial response, I don't have specific advice, but I would say just the fact that the nature of the problem of broadening participation and the fact that we're, making change incrementally, is, a testament to the fact that this is not something that can be changed overnight. I would say, I may have to come back to this one. because, you know, you can look at the STEM community and STEM education community is a, you know, a subset of society as a whole. And if you look at the time, you know, how it's taken years to make changes in society, you know, in terms of STEM, we have to use some of the same, I would say, apply some of the same strategies and some of the same research, proven research to have an impact. So I'll come back to that one. I don't want to just, you know, sort of ramble without providing a substantive response and the research to support it. So while I'm thinking about that, I'll answer other questions. And if I don't come up with something while we're talking, I will have to send something, a follow-up, because there's a lot there. One thing I can think of, I would say, relates to my own research that I'm particularly interested in, which has to do with identity and how people view individuals from different groups that are perhaps have not been, you know, participating in the STEM enterprise. So, you know, women, for example, are still extremely underrepresented in the physical sciences. If they are fortunate enough to get degrees in physical sciences and physics and chemistry and math and physical sciences, then they go into an environment that is still may often be very male dominated. So what does that mean for them? They ideally, there are people who would be, you know, welcoming and inclusive and enable them to feel that they are, you know, can contribute in whatever way that they've been, you know, their position reflects. But part of it, so part of it has to do with how they're viewed and also their own sense of who they are and whether or not they view themselves as being, you know, a scientist, whatever, in whatever field they're in, being competent, being able to contribute to the research enterprise in different ways, and being recognized by their peers as being on the same level as them. So there's been a lot of research on identity, and the characteristics that I mentioned are part of the work by a woman named Heidi. Now I'm blanking on her last name, but I'll put it in the chat. There's a lot of research on different ways that identity is viewed, but that particular model doesn't put all of the responsibility on the individual. It also requires that the environment that they're in, the individuals that they're working with, also recognize them as being a part of the STEM enterprise. Heidi Carlone and peers. So STEM identity is one thing. And so the only other thing I'll say about this response at this time is that people have recognized that not only, it's not enough just to have the intellectual ability to succeed in, and this is for K-12 students as well, to succeed in a field. a lot of what people refer to collectively as non-cognitive factors, like identity, like, ways that you view yourself, self-efficacy, and other characteristics that, are associated, that move beyond just the abilities, are important for people to succeed in STEM fields. But on the other hand, there's also a ton of research on strategies that have been effective in supporting individuals to help them to become engaged and sustain their interest in STEM, even if they come into a few roadblocks. Mentoring, peer groups, study groups, research experiences. I can't emphasize enough the importance of research experiences, not only at the undergraduate level, but also in high school, as well as opportunities to do science in the way that professional scientists do. So that means participating in research, but also presenting research and engaging in science. So you really get a sense of what it is. It's not just, you go into a lab and you do one experiment and you solve the problem. Understanding that the research enterprise, requires a lot of commitment, but a lot of teamwork, as was mentioned as I mentioned in the presentation as well, that you work as teams and everyone can contribute. So being able to be part of a research team is also something that research has demonstrated can be effective for retaining young women, as well as people from underrepresented groups in STEM. So I've just touched on the surface there, but happy to share more research with you.
We have a great question in the chat from Sarah. She says, our undergraduate students are critical agents of change in the First Two Network, helping themselves, helping others, and helping to change the system. What advice might you give directly to our student change makers?
I guess I would say, don't give up. I know this may sound very similar to what you've heard, but persistence is the key. I would say, I'll speak from my own experience. Sometimes you find mentors in places that you may not expect, and you may have multiple mentors. Your mentors may not all look like you. I know there's a lot of research that says, we need to have mentors that are, from the same backgrounds as the students. And that's true. That's very helpful. But I've had multiple mentors and mentors along the way. Once you graduate from college, that doesn't mean you stop benefiting from mentors and mentorship. So, I would say be persistent. And when I say be persistent, what does that mean? It means that you may not be able to go to school full time without working or caring for your family. I've worked throughout my undergraduate and definitely through my graduate career. When I was working on my doctorate, my children were also in college. We were all three in college at the same time. So not only was that crazy, but have you ever heard the expression robbing Peter to pay Paul? So there were these financial challenges, that I was trying to, okay, if I pay his tuition, then I can pay mine next. And so, it is, don't let those things that may seem like insurmountable barriers hold you back. It may be that, there be periods where you're studying, where you're in college, and the only thing that you have to worry about is studying and working on your classes and being successful. but there also may be times where you need to work, or you have family members that need your support, or the financial part of it seems like it's, just not going to work out for you. My own personal background is that, my family probably didn't meet the criteria for middle class. So, I did not have a whole lot of money. In fact, I had no money for undergraduate school, to be quite honest with you. But I was able to get grants and scholarships and fellowships throughout my academic career. And when I finished my bachelor's degree, I thought, boy, I'm glad that I was able to do that. And I didn't really plan to go on beyond that. But, I had other opportunities. I started my master's degree. I took a couple of classes at Johns Hopkins. At that time, I was married and had children. And then I got a job at Johns Hopkins. Lo and behold, you get free tuition if you work for Johns Hopkins University. So you never know what opportunities will come your way. And then, as I said, when I was working on my doctorate, my children were in undergraduate school at the same time. So I had to be creative in terms of, working more than one job and doing things to ensure that, we would all finish with as little debt as possible. So I hope all of that sort of unpacks that be persistent, don't give up, that you sometimes hear people talk about. It means that you will encounter roadblocks, but whatever roadblocks you encounter, you can probably, talk to someone like me that has gray hair that will say, yeah, I had those things, and this is what I did to, move forward. And it wasn't easy, but I got it done. When I finished my doctorate, I was working full time at NSF. I was commuting 2 hours to work each day, and 2 hours back home, of course. It was insane, but I finished. And so my other advice would be to go to school while you, as much as possible, get as much done before you get to the point where you take on these additional responsibilities, such as, other commitments, family, and so on. If you have a family, doesn't mean you can't get it done. It just means it's a little more challenging. So I think I'll try to answer one more question really quickly before I go to my next meeting. What do you suggest? Biology degrees.
There was a lot of commentary.
Okay.
You're talking about the importance of being in research experiences and
yes,
how that aids persistence. It garnered a lot of affirmation from people out there.
Right. And I see a comment about presenting research as, I'm not sure what, a West Virginia something standards for high school or undergrads with college, and providing technical support and incentives and professional partnerships, especially for high school teachers. Yeah, I mean, the only thing, I'm not familiar with the different programs in West Virginia, but I'll say that if there isn't a research conference for high school students that your students can participate in, some schools get together and create their own just so they can have that experience. I know that's also a lot of work, but that's also something can be done, sort of going beyond the science fair model to having students present to peers at a minimum. And it can be as big or as small as you have time for and resources. So I hope this helped. I know I rambled a little bit with some of the responses, but hopefully it made sense. I really appreciate the opportunity to chat with you. If you have any other questions, I'll put my email in the chat, because I know I could not go into detail on all the questions. Drop me a line. Don't get discouraged if I don't answer right away. I will do my best to get back to you within a week. I hope that you continue to have a very successful conference. First to STEM is doing great work. We're happy that you're a part of the NSF Includes National Network. And for those of you who are not, have not joined, please do so. There are resources for, organizations at many levels that have an interest in broadening participation in STEM. Thank you. Have a wonderful afternoon.